with the other topics.
Do you have any question from previous?
Or maybe you have feedback, or is this do you have any suggestion that we should including in this topic? Maybe any question from your side? No? Jackson maybe? Jason?
Or Ahmed,
Ahmed?
any question? If you don't have any questions, so we assume that you understand from our previous day, but no problem. If you have any question, you can ask. Jackson, do you have any question from previous class? A
No questions for now.
question?
Maybe as we progress, if I find any challenges, I may ask. But for now, I don't have any questions.
Okay.
All right.
So
Okay. So,
I will send you our recording. So today after class, I will send you our recording to your email. So you can start to do your capstone. And if you have any question when you listen our recording, you can just ask. Okay, maybe we can continue
yeah.
our class, yeah.
So we will continue with the other topic. Right now, we will discuss about the three-dimensional weight and COG. Before, yesterday we have talked about the two-dimensional and the single line weight and COG. Now we're talking about the three-dimensional weight and COG. For the case one, we have three items: the blue, yellow, and the green item, as shown in the drawing. The dimension is 10 meters by 20, and the the origin point is here, right? So the x positive axis is here, the y positive is here, and the z positive is here. And we want to find the total weight and the COG, combined COG of these three items. Actually, there is no other formula that we can use for this. The only formula is the one we have discussed about for the line one member COG. So just to flashback with the previous one, the formula will be like this. COG is P1 times X1 plus P2 times X2 plus it divided by total weight, total load. So if you want to find the coordinate X of the COG, then you use the coordinate X of each parts of or each items in the formula. If you want to find the COGY, then you can use the COGY of each item on the formula. And also with the COGZ, then you use the COGZ of each items. So right here we have three items. Currently is item one, the weight is 600 kilonewton. And then item two, the weight is 300 kilonewtons. And the item three is 500 kilonewtons. And the COG, I assume it will be at the center of the each items. So for the COGX, for the item one is it will be on at the 10 meters from the origin point, and the y is 5 meters from the origin point, and the z is 1 meters from the origin point. The for this we need to consistent in using the in measure the COG position or location. We should use the same origin point for the each item. So make sure that you have uh, a clear origin point before you start to calculate the COG. So yeah, for the item two, the COG X is 8 meters and COG Y is 1 meter, and the Z is 4 meters. And for the item three, the green one is 17 meters for the X, 5 meters for the Y, and 4.5 for the Z. Now with the same process as the previous day, we have discussed that to get the total weight, we just easily just sum up all the weight P1 plus P2 and P3, 600 plus 300 plus 500, we get the total weight of 1400 kilonewtons. And for the COGX, we can find with the same formula, P1 times X1 plus P2 times X2 plus P3 times X3. So we have three items, then it only until P3. If you have more than three items in the systems, then you can adjust with the how many items you have. For example, if you have 5 items, then it will be on until P5 times X5 like that. And then we divided it by the total weight, P total. And then we got the COGX will be on 12.1 meters. Same with the COGY, we use the same formula, P1 times Y1 plus P2 times Y2 plus P3 times Y3, and then divided by the total weight. We get the COGY is 4.14 meters. Same with the COGZ, we use the same formula also. The difference only we use the coordinate Z in the formula. So we get the COGZ is 2.89 meters. So that's the COG calculation for three-dimensional. Now the problem is how can we find the lifting point reaction from the COG and weight information that we have calculated. Usually the COG Z is not, we it's only used for the stability studies. So for the lifting point reaction, we can only use the COGX and COGY. So from that, we only use the COGX. This is the COGX that we found previously. COGX is 12.1 meters and COGY is 4.14 meters. So we have discussed about this yesterday. So we can distribute this load to each sides of the structures or the object. For this case, I will distribute this load first to this side. But I put disclaimer here that this only works for a rigid object. So it will be like equipment or machinery like that. For a structure, we should introduce the uh, deflection and elasticity to get the lifting point reaction correctly. So just remind that this only works for a rigid structures. So we will distribute this to this side first. So if we look at this direction, then we will get to into this system. So crane 1 plus crane 4 will be at the left side, and the crane 2 plus crane 3 will be at the right side here. This is crane 2 and plus crane 3, and crane 1 and crane 4 will be at the left side, and the load will be sitting exactly at the 12.1 meters from crane 1 plus crane 4 here, this one. So from this, we can find the reaction for the crane 1 plus crane 4. We can use the total moment at crane 2 plus crane 3 equals 0. Then what is the moment acting on the crane at this joint? It will be crane 1 4 times 20 meters, the distance to the crane 2 plus crane 3, minus P total, or the total weight, times 7.9, the distance to the to the crane 2 plus crane 3. So we got crane 1 for 553 kilonewton. And then we continue to find the crane 2 plus crane 3. We use the total moment at crane 1 4 is 0. Then the crane 2 3 times 20 meters, the distance to crane 1 4, minus the total times 12 meters. That's the distance to the total weight, or the COG, at the X direction. And then we got the crane 2 3 is 807 kilonewton. From each reaction. So we have find the crane 1 4 and the crane 1 2 3. Crane 1 4 will be sitting at here. Crane 2 3 will be sitting at here, and we will distribute this to each lifting points. So I will see to this direction. So the crane 1 will be sitting at the left, while the crane 4 will be sitting at the right side. And the load itself, I will say this crane 1 4, it will be 4.14. This total will be 10 meters. So this will be 5.86, like that. So from that, we can find the lifting point reaction for each cranes, crane 1 and crane 4. For crane 1 and crane 4, we will use the reaction from crane 1 and 4. For crane 2 and crane 3, we will use the reaction from crane 2 plus crane 3. So we start from the crane 1. For the crane 1, we will use the crane 1 plus crane 4 here, 533 kilonewton, which is sitting on at the 4.14 meters from the crane 1. It's exactly at the YCOG of the structure. So, and then if we want to find the crane 1 reaction, then we use the total moment at crane 4 is 0. Then crane 1 times 10 meters for, or crane 1 4 times 5.86 meters, the distance of the load to the crane 4 here. Then the crane 1, we can 4.1 kilonewton. for the crane. We use the was
I think that Nelson voice is a little bit break, or only
Yes,
for me, or
it's
only
breaking.
for all of you.
Yeah, I believe
times
there is a
equal
network
28
problem.
point.
Sorry, yeah, give him time a little bit, maybe with connection. And now come back.
Was
We cannot listen you very well before, Nelson, so maybe you can repeat.
okay. Hello.
Yes, now it's clear.
Okay, it's clear now, yeah.
Yeah.
So from which part you didn't hear it well? Should we start again from the beginning?
No. Just the last page itself.
The last pages.
Yeah. Where
So
were you at the moment? Yeah.
this one. So yeah. So we continue with the lifting point at the crane 4, then we use the total moment at crane 1 equals 0 here. What is the moment acting at the crane 1? It's crane 4 times 10 meters, the distance to the crane 1, minus crane 1 4 times 4.14 meters. That's the distance to the from the load to the crane 1. And then we got the crane 4 equals to 228.9 kilonewton. After we got the crane 1 and crane 4, then we continue with the crane 2 and crane 3. For the crane 2 and 3, we will use the reaction from crane 2 plus crane 3 equals 847 kilonewton here. The same process as we got the crane 1 and 4. If we want to get the crane 2, then we use the total moment at crane 3 equals 0 here. And then the crane 2, we get 496.3 kilonewton. And then for the crane 3, same process, we use the total moment at crane 2 equals 0. What is the moment acting at the crane 2? It's they are crane 3 times 10 meters minus crane 2 3 times 4.14 meters. So we got the crane 3 equals 350.7 kilonewton. After that, we do the equilibrium check just to make sure that our reaction are correct. So total force equals 0, crane 1 plus crane 2 plus crane 3 and plus crane 4 should be equal to the load acting on the system. And we get the total force equals 0. Then it's we are on the equilibrium. That's for the reaction for the lifting point calculation. Any question up until this? So yeah, we for lifting point reaction, we just use the COGX and COGY, while the COGZ we use that for the stability studies. I will explain after this how can we use the COGZ for our calculation. Any question?
Nothing from my side.
All right. We continue with the new cases. So
Mr. Nelson, Mr.
yes,
Nelson,
yes, Ahmed.
you are saying, yeah, you are saying about for the lifting point reaction, we just need X and Y. For Z, we don't need for Z, we need just for a COG calculation, all right?
Yes, correct.
All right.
Or maybe you have different thought. we can discuss about this. Ahmed.
No, I understand that. I don't have a point. If I have a point after that, I will.
Yeah, sure,
Talk.
sure, no problem.
Okay.
So we continue with the new cases. Yeah, the case two is we have a structures jacket here, and as we seen at the table at the right side, the mass is about 358.46 metric ton. This is real cases that I've got from real project. As you've seen the COG, I calculated manually by using the drawings just to make sure that the what I've input in the software is already correct or not. So I always refers to my manual calculation before I get into the software. This is the same process or the same basic that I've used for the real case. Same formula like previously we have discussed. So we have the COG, the total COG we've seen here, right? And then the total mass is 358.46. And then there is not much. It's about 20 tons with the software. I use SACS for the analysis, and it's showing that the mass from the software is a 331.56. So there's a lot of difference between the software and the manual calculation. But of course, I will follow my manual calculation and adjust the SACS software to follow my calculation. The problem here in this case is this jacket is going to be transported by using SPMT with the 4 groups hydraulic with 100 kilonewton scaffolding installed at the top elevation. Calculate the weight, COG, and reaction of each hydraulic groups. So the COG one is the item one is the structure itself, and the item two is the scaffolding. We plot the COG for each items. The COG one, if for the plan view, we get the COG one is 10.008 meters from the our origin point, while the COG2 is at 10 meters for the X direction from the origin point. And the Y distance is a 9.996 for the item 1 and 10 meters for the item 2. And the Z direction is COGZ 20.442 meters for the items 1 and 37 meters for item 2. And then we continue with the total weight. Total weight is first we find the weight of the structure before the information saying it's on mass. So we need to convert it to be weight. The mass is a 358.46 metric ton. Then times the gravity 9.81. Then we get the weight of the structure is 3,516.5 kilonewton here. And then weight the scaffolding is 100 kilonewton. Then the total weight is 3,616.51 kilonewton. And then the combined COG is the same process as previously. The to get the COGX, then we use the formula with the COGX for each item here. P1 plus P1 times X1 plus P2 times X2, then divided by the total weight. And then we got the COGX is 10.008 meters. That's for the COGX. And then COGY, we just change the coordinate per items become the using the coordinate Y. So we get the COGY is 9.996 meters. And then the COGZ, we also use the same formula, but we need to change the coordinate become coordinate Z per item. Then we got the COGZ is 20.9 meters. So the combined COG will be 20.9 meters at the Z direction. And for the elevation, nothing much different with the structure. So it's not much impact. The scaffolding itself, not much impact to the original COG. It's still same 10.008 meters for the X and 9.996 for the Y. But the difference is only at the Z COG. And then how the SPMT works for this, the grouping works only the each groups. For example, we have 6 axles on this SPMT, right? To make it one group, then the load works on these groups will be at the center of this group. So this is the axle of the SPMT. 1, 2, 3, 4, 5, 6, and then we combine all this SPM, all this axle, and the reaction will be work at the center of the grouping here. So because the legs sitting exactly at the center of the groups, then it will be same as we find the reaction at the legs itself. So the distance for each for the legs is here 20 meters, 20 meters by 20 meters, and the COG will be at the 10.008 meters at the X and 9.996 meters for the Y. So our origin point is here. This is X, this is Y, right? So it will be same as we find the if we want to find the lifting point reaction. So how to find that? Then it will be same process as previous. I will distribute this to this direction and this direction. So for this, I will see this side. Then the group 1 and 4 will be at the left side. Group 1 and 4. And group 2, 3 will be at the right side. And the COG will be here. (10.008) and this will be 9.992. From this we can continue with to find the group 1 and 4 first. To find the group 1 and reaction, the 2, 3 minus P.992 meters. So we can find the 4 is 1,806 0.8 Newton. Same with the group 2-3. We use the total moment at moment acting on the group 4. It's they are group 2-3 times 20 meters minus P total times 10.008 meters. Then we group 3 1809 kilonewton. After that, we continue with the distribution the
Breaking again.
I think that your
we
voice,
use group 1 for 1.
I think that your voice not sorry, we cannot listen you very well before. Hello Nelson, we cannot listen you.
Hello.
We cannot listen you very well. Try again.
Hello.
Yeah, now we can listen.
Okay.
Okay, now it's
So we continue with the after we get the group 1-4 and the reaction and the group 2-3 reaction to find the each group's reaction. For example, we want to find the group 1 and group 4 reaction, then we use the reaction from group 1 plus group 4. So yeah, group 1-4 we have found that it's 1806.8 kilonewton and the location is 9.996 meters from the group 1. And the group and to find the group 1 we use the total moment at group 4 equals 0. What are moments acting at the group 4? There is group 1 times 20 meters, group 1 times 20 meters, minus group 1 4 times 10.004 meters. So we got the group 1 is 903.8 kilonewton. And then for the group 4, to find the group 4, we use the total moment at group 1 equals 0. So we get the group 4 times 20 meters minus group 1 4 times 9.996 meters equals 0. Then we get the group 4 is 903.0 kilonewton. Like that. That's for group 1 and group 4. And then maybe you can help me to find the group 2 and 3 here. So for group 2 and 3 we get before we have 1809.7 kilonewton here, and then the distance is group 2-3. This is a 9.996. The total is 20 meters, so this will be 10.00. Sorry, 18. Yeah, same like this, but the group 2-3 is 1809.7 kilonewton. Group 2, group 3. All right. Anyone can find the group 2 and 3.
let's start calculate, right, Nelson?
Yeah. Anyone?
Anyone can
Any-
help Nelson? Maybe Jackson, Aiman, or Jason, or Ahmed?
For group 3, I got 904.5.
904.5.
Group 2, 905.2.
905.2. Group 3, 904.1.
0.5.
0.5.
How about Jason, Ahmed, and Jackson? Do you have a different answer or the same?
Same answer, R3 904.5.
Hmm? Okay, so you have.
Same answer.
Yeah.
All right.
How
So
about
let's see. So yeah, group 2 we get 905.2, and group 3 we got 904.5. So the process is same. Group 2 3 is the total group 2 3 1809.7 kilonewton, and it's sitting 9.996 meters from group 2. To get the group to find the reaction on the group 2, then we use the total moment at group 3 equals 0. What are moments acting on the group 3? They are group 2 times 20 meters minus group 2 3 times 10.004 meters. So we got group 2 905.2 kilonewton, and for the group 3 we use the total moment at group 2 equals 0. So we get group 3 is 904.5 kilonewtons. That's for the reaction of the hydraulic group of the SPMT. Yeah. And then we check the equilibrium. The total force is equals 0. And group 1 plus group 2 plus group 3 and plus group 4 minus P total equals 0. Then we are good. We are in the equilibrium. That's all. And for the Z COG, we use that to check the stability during transportation. So, for example, this is the combined COG, and the SPMT, our SPMT are sitting here, right? And from this, before we get to here, we need to know what is the uh tilting area or tilting line. So to get the tilting line, we just need to to make a line continuous at the center of hydraulic group. So the tilting line is tilting area is here. As long as we get the COG, the combined COG inside this area, then we are okay. But there is also that we should check calling tilting angle. The tilting angle is like this. So we have the SPMT we put here, and the tilting angle will be this. So to find this angle, we need to know where is the COG Z of the combined COG structure. So once we get the combined COG, then we can find the tilting angle and compare to the allowable angle as per the requirement of your project. Sometimes it's 7 degree. Some projects use 9 degrees, like that. So yeah, that's for the hydraulic groups of the SPMT, and how to find the reaction based on the COG. We only need the COGX and COGY to get the reaction of the each hydraulics group. But how about if the so there are two hydraulic groups that we usually use in the SPMT design. They are four hydraulic groups, and the second is three hydraulic groups. If it's hydraulic groups, then we need to combine these two SPMT or two axles as a one group. To make it as a one group, then the center of hydraulic group will be at the center of this combined SPM axles. So the tilting line will be different. It's not longer like this, but now it will be like this, like that. And the calculation for the reaction of each groups, it will be different because it's now we have three supports of hydraulic groups. But for this, we need to distribute to each line first, which is perpendicular to the side of the triangle. And then we combine the reaction. For example, if we want to find the reaction for the triangle, then we need to distribute to this first, to this line first, find the reaction from group 1, group 2, and group 3. So first we find the group 1 plus group 3, and then we continue with this group 1 plus group 2, and then we continue with this group 2 plus group 3, and we combine all of them like that. That's for the SPMT hydraulic group. And then we continue with the structure tilting estimate during lifted. This I just want to show what is the effect or impact of the Z COG to our lifting arrangement. So this is the same structure as before. We have a jacket 20 by 20 meters. The total mass is at 358.46 ton, and the COG same as before is 10.008 meters at the X direction, 9.96 for Y, and 20.442 for the Z. This jacket will be lifted by using a single crane. Determine hook position if the minimum requirement of rigging angle is 60 degree to the horizontal. I think it's it's a easy one for you guys because you're familiar with this. To determine the hook position, we usually put the hook position exactly at the hook location, correct? So now, once we get the hook position, COG location, we have the COG location here. Then we can put the hook exactly at the COG position. So it will be in line with the COG position. We say the rigging height or hook location is at edge height from the lifting point. Let's say the lifting point is here. And then to design the rigging, then we need to find the horizontal length of the from the lifting point to the COG. So the horizontal length of the rigging is this. So let's say this is the LX that's for the rigging 1, and then for the rigging 2 is here, and rigging 3 is here, and rigging 4 is here. So that's the horizontal length of the rigging. How can we calculate the LX? It will be square root of 10.008 square, this 9.996 square, like that. And that's for the rigging 1. How about the rigging 2 is square root of plus 9.996 square. And also with the rigging 3, we can find with the 9 square root 9.2 square plus for the horizontal length of the rigging. Horizontal length of the rigging. After we found the horizontal length, then we continue with the to find the height of the rigging. If the allowable angle is 60 degrees, so we can use this formula to find the height. For rigging 1, for example, we have the LH is the horizontal length. LH is 14.14. Then the height, if the with the angles 60 degrees angle, we got 24.49. For the rigging 2, the rigging horizontal length is 14.13. Then the height will be 24.47 if the minimum 60 degree. So this height is based on the angle 60 degrees.
Your voice is breaking.
All
Donald.
this rigging. Hi, hello.
I think that your voice unstable, or maybe you can switch off your camera. Maybe it will better.
Okay, I will try. Check. Is it good now?
Now it's okay.
Yeah.
Yeah. So so this height that we found here is still the minimum requirement to fulfill the requirement that the allowable angle is 60°. But if we put this rigging into the structure, it will not meet at the hook location. So we need to find the hook height minimum. The hook height minimum is the highest height of the rigging, because if we use the minimum, for example, we have here is a 24.47 meters height. If we use this as our reference to design this rigging, the rigging for the angle of this rigging will be less than 60°, and it's not meet the requirement that the allowable angle is 60°. So we need to use the maximum height as our reference, the 24.51 meters, like that. So when we get the 24.51 meters of hook height minimum, then we can recalculate the requirement for rigging 1 and rigging the other riggings. For example, for the rigging 1, we will change the height as 24.5 meters. If this 24.51 meters, then the angle will be different. 14.14 times let's so tangan equals h divided by LH. The h is 24.51 divided by the LH is 14.14. So the angle will be 24.51 divided 14.14, 60.02 degrees. So it will be more than 60 degrees that meet our requirement, more than 60 degrees. So yeah, so the hook height requirement, our requirement is 24.51 meters. Now the next question is, if the actual hook point is located at 50 millimeters toward X plus and 30 millimeters toward Y plus from the original design, calculate the tilting angle that could be happen during lifting. So if the hook position is shifted 50 mm to the X positive and 30 millimeters to the Y positive. So the absolutely the structures will be tilted, but how much it will be tilted, that's the question right now. To calculate the tilting angle of the structure, we need to know how will the structures response to the different COG, to the different hook location, like that. So as I mentioned before, that the structures will be tilted. That's not because that's because the COG, the structure itself, to find the equilibrium, to fulfill the equilibrium of the system. So when this happen, like when this happen, it's not longer exactly at the same line. The COG and the reaction and the action is not longer at the same line. here. To fulfill the equilibrium, then because there is the eccentricity here. To fulfill the equilibrium, total force equals 0. This action should should move to the hook position, so it will be in line, exactly in line with the hook position, which is the reaction of the structure. So the to fulfill the equilibrium, the structure will be moved about an angle that so that the equilibrium will be fulfilled as our requirement. That's the process of the structures to get into the equilibrium. So in this case, we have eccentricity here, and then we have the hook is shifted from the original COG. This is the initial COG, and then the process will be, the structure will be tilted until the COG move exactly in line with to the hook here. So we have this initial COG will be moved to the final COG. And to find the angle, we can easily use the trigonometry here. So the distance COG to hook, we have found the distance to the COG to the hook is 15.6 meter plus 1 meters. That's the lifting point. And then we have h, or the hook height, we have found 24.51 meters. So the distance COG to hook is 41.11 meters. And then the shifted to the x positive is 50 millimeters, as mentioned in the before. It's equals to 0.05 meters. So we can find the structure will be tilted toward the x direction, tangent arcus tangent delta 0.05 divided by the distance COG to the hook, 41.111. Then we get the angle toward the x, 0.0969 degree. And for the y, we get the 0.03 meters shifted. Then we get the angle for at the y direction, it will be 0.042 degrees, like that. Is there any question for this calculation to find what is the impact for about the z direction of the COG to our lifting arrangement? This methodology also can be used for to find the COG if we doing weighing using lifting method. So during the lifting we can calculate, or we can measure what is the angle of during the lifting. Then from the angle we can estimate where is the COG of the structures. So we can doing the reverse engineering to find the COG, like that. Is there any question for this
Well, this is very long calculation, yeah. Very long calculation. So, do you have any question regarding to this question? If you have any question, you just raise your hand or just speak up and ask your question to Nelson. Jason, Aiman, Jackson, Ahmed, do you have any question? because this is very long study case, and we have to calculate and understand very well. Do you have any question so far? All still okay?
Okay, the main important thing is that we understood the concept, what are the requirements. Yeah, the calculation is quite a lengthy process, but knowing the bits and pieces, what is all required, that is covered.
So, any question, Jason? Well, with regards to this
Got a
calculation.
fair idea, fair concept of it.
Sorry?
Yeah, I got a fair idea like now what exactly is required. No questions.
No question. So, is it do you familiar with the calculation before? I think it's
No, not much we have used.
yeah, because I think it's same, maybe same thing, yeah, but different approach from every engineers, right? Sometimes it's so I think it's the same concept as for every engineers, but maybe they approach have a different because every engineers have a different approach. Though I hope this not really confusing for you to get into this methodology. So yeah, Ayman maybe. Ayman from Mammoth, right?
Yeah, Nelson.
Yeah. Any question about this?
Uh, I think not much question, but let's say if the client change maybe added any items to the structure, and then the COG will be shifted, then we need to recalculate everything
Yeah.
again.
Yeah. Not actually, not everything. Later, we will discuss about this because there is some requirement that we allow until certain distance of the COG shifted, then we are still okay with that. But when the COG shifted far from the certain uh, allowable, then we need to calculate. So we need to uh, I will explain later about that. So
Yeah, okay.
not every modification we need to recalculate like that. It will be wasting time, right?
Yeah, okay.
Any question? Maybe Jackson Ahmed. How are you, Ahmed?
Jackson, do you have any question? Because now
Uh,
so you can ask or say something to Nelson.
I'll just have to go through, but I'm getting the message from Nelson. Yeah. So I'll just need to get more details. I'll just need to go through. So to avoid wasting time, maybe we can progress. But I'm getting what he's explaining. Like you have said, you share the video for the lesson, then maybe I'll just need to go through a bit more, especially on the targeting the turn angle there. That's where I'll need to just maybe go through. But the rest of the things Nelson is saying, I'm getting. Yeah.
All right, Jackson. If you have a call, if not only Jackson, but maybe you guys have a question after this program, you can feel free just ask me directly by message or anything else. No worries about that.
Yeah, for me is also if we go through it, no, it will go very far. So we don't have time. We need to go for the next step. If anything else after that, when we will practice, then we can talk through WhatsApp.
All
Simple.
right, sure,
Yeah, yeah,
sure.
sure, Ahmed. Because our case study is rely on study case on site. So we understand that you need time to understand when you go through our recording video or when you go through your capstone project, you will find exactly what you wanna ask. For example, you can ask Nelson anytime. So,
Yeah.
we understand this. So that's why we create capstone project for all of our participants for them to exercise more based on our topic. So that's why our participant they love our capstone project because during that period when they start to exercise through the capstone, they learn more and they will understand more about our topic.
All right. Yeah. We will continue the next topic. Yeah.
Yeah.
So the next topic will be about the. So the calculation is only up until the part three. The next part is only the theory, I think. So the part four will be what is the net weight, gross weight, and NTE weight. So in the lifting operation, we always refers to the to the gross weight. So for me personally, I never use the net weight. So the net weight is the weight of an item without allowance. So that's the really basic net from that we get from the drawings or the uh, weight control report like that. So this is the actual weight obtained from manual calculation or by using software or from the drawings itself, while the gross weight is the weight of an item including allowance. So the gross weight is net weight times weight contingency factor. And the weight contingency factor is we can refers to the codes or like DNV or maybe the project requirement and the client has their own requirement for that. So we follow that. This is the weight used in the lifting or transportation analysis, while the NTE weight or not to exceed weight is the maximum allowance weight limit. It's we can use the NTE weight, but it will be no longer efficient to the design. So this is what I get from the ISO 19901. There there are some stages or phase of for the one project. As we seen in the graph is the network is always going up here. This is the stage for the basic design, and this is the stage for the construction during construction, and this is during the operation. During the if we look at the gross weight here, this is the estimate. It's the estimated weight with the weight allowance here. So we always refers to the gross weight for the lifting design. Why? Because for example, during the basic design, the net weight is here, right? During the basic design, it will have weight bigger weight contingency factor to introduce the weight allowance here. It has a big gap to the gross weight rather than the gross weight. It's okay if we use the basic design drawings for the installation, for example, but we need to consider the bigger weight contingency factor to get the uh, gross weight correctly here. So if we continue with this contingency factor, this is I refers to the total specification, and I believe that there is a such same factor from the DNV or ISO. If we look at here, the basic design has a more factor than the detail engineering and the construction here. That's to uh, compensate the wake allowance, because during basic engineering there will be a lot of modification that can be done up until the construction end. So to compensate the modification, we need if we refers to the basic engineering design, then we need to apply these factors. That's a big factor: 15%, 20%, 20%, 25%. But if we use we refers to drawing as per the detail engineering or the construction, we will use the smaller weight contingency, because there is small possibilities that the design will be changed much like that. So for the detail engineering, so the point is we need to know the drawings, what our reference to do the study. Either it's a basic engineering drawing or the detailed engineering drawing. We need to apply the contingency factor, and the contingency factor will be uh, according to the stages of the drawing itself. So yeah, be wise to choose the weight contingency factor. And from this table, we see I get this from the ISO also. So ISO have classification for each structures that they put is class A, class B, and class C. The class A is a new concept type, weight sensitivity high, COG sensitivity high. It means it's like maybe a new platform or a new jacket that if any modification on the platform, it will be shifted the COG far from the original one. So if that the case, then we will classify that as a class A. If class B, it's we can assume that it's part of the platform itself. So maybe one level of the platform that we can consider as a class B, and the class C is it's like the equipment of the platform itself. So yeah, that's this will be we can use this classification to determine the which part of the where's where's the object class of the one our case. So yeah, that's all. And then beside the weight contingency, to get the gross weight, also we need to consider the COG uncertainty. There are two methodologies that we use to consider the COG uncertainty. First is a COG envelope, and the second is a COG factor. COG envelope is one of the methods used to test the design for uncertainty in the COG. generally used for structure item class A as per ISO, like this. So if it's a new concept, weight sensitivity high, COG sensitivity high, then we can use the COG envelope to in our analysis. How to use the COG envelope? So I refers to the total GS here. It is saying that the extremes of COG envelope centered on the calculated COG which corresponds to a rectangle whose sides are. So let's say we have a platform here, right? We have a platform here and it's 10 meters by 10 meters. And the COG is here. Let's say here is 7 meters, and this is 4 meters. How to apply the COG envelope on this platform? So the COG envelope, we can put this COG, the original COG, in the box like this, and the COG we will put the new COG at the corner of the box here. This is a imaginary COG, yeah. So we have 4 imaginary COG. Let's say it's a COG1, COG2, COG3, and COG4. And this is the original COG. Now, where is the location of the COG1, 2, 3, and 4? It will depends on the size of the COG envelope or the box itself. In the as per the total GS, it is saying that if it's a square for a deck, it will be 10% of the overall width and length. So it will be 10% of 10 meters. It will be 1 meters. And this 1 meters. And this original COG will be at the center of the envelope itself. So if it's 7 meters here, then the COG1 will be the COG1 will be 6.5, yeah. 6.5. Oh no. Yeah, 6.5. It will be 6.5 to the COG1 and 4. 6.5. And to from the we get the 3.5 from so we have COG 1, 2, 3, 4 that we will use in our analysis. So we now have 5 COGs for, as 5 cases for the analysis. Once for example, for the case 1, we use the original COG in the analysis. Find the lifting point reaction here with the COG, the original COG. That's for the case 1. And then we continue with the COG1 here. We use the COG1, the imaginary COG, to calculate the lifting point reaction here. And then the case 3 will be the COG2. We put the COG here and to calculate the reaction, and so on with the 3 and 4. Once we get the lifting point reaction based on all the COGs, we compare them and find the maximum reaction. Then it will be our basis for the lifting design, like that. That's for the COG envelope. And then we continue with the COG factor. For the COG factor, we just simply apply a factor to the gross weight like that. So before we have the gross weight equals net times contingency, weight contingency, and then as per total GS, it's 1.05. So yeah, it's different between COG envelope and COG factor. Now, if any modification that's happened during the project, and if if the COG, if the modification impact to the COG, as long as it's inside the COG envelope, then we don't need to redesign of the lifting arrangement. We can because we have designed it as per the maximum load, which is at the corner of the COG envelope. But if the COG after modification out of the envelope, let's say here, then we need to redesign the lifting arrangement for that. Yeah. So that's the purpose of the CIG envelope like that. Any question up until here? I think that's all the topic for the lifting for the weight COG and load distribution.
Yes, any question from all of you? Any question from all of you? If you don't have any question, maybe we can go with capstone project. We can try to explain a little bit about capstone project. But if you have
All
any,
right, we continue with the
feel free to ask.
we will continue with the capstone project. Yeah. So this capstone project is yes, it's very slow. Is there any question while we are waiting for this download? This is, I think I have problem with the with the internet here.
Yeah, sometimes we have a problem with internet connection. So do you have any question?
I got one question.
Okay,
Yeah.
go ahead, Aiman.
Because the COG envelope is like
Yep.
the percentage for the COG can be shifted.
Yes.
That one, it is shifted. Is it on the ground or while it is lifting?
That's we use for the all things. So it's not limited only during the on the ground. We also use that for lifting arrangement design. So yeah. So it's really useful to know if it's required, if there is a modification on the let's say so structure or platform. If any modification on the structure, then that will tell us if we need to do some re-engineering on the structure itself or modification like that. So it's not limited only to the above ground, but also we can use that for during the lifting arrangement design like that, Ayman.
Oh, I see. Meaning, let's say during the lifting, if got any external forces that can make
Mhm.
the COG shifted, also it must be inside the COG envelope.
Yes, correct.
Okay. Thank you, Nelson.
Thanks. So yeah, we continue with the capstone project here. So this is the capstone project. We have four exam here. So this is the first. It's a simple beam like this. We have one distribution load 10 newtons per meter here, and then we have a point load at the cantilever at the left side of the B. The question is find the reaction at joint A and B, and number two is find the COG location. It's the same process as previous yesterday. So nothing's I think is clear here for this. The second one is we have a mobile crane here, right? So we are going to find the COG location for this crane during the lifting. So the load will be at the here. We have load here. We have boom. Boom is here, and then the carrier, let's say here, and the counterweight is here. So the COG of each items for the load, boom, carrier, and the counterweight is on the table as you see in the X and Y, and the weight of each item also in the table. You only need to combine by using the formula as we got yesterday. This calculation is help us to find once we get the COG, then we will easily find the outrigger forces from each outrigger. Let's say the outrigger here, right? And then we find the COG here. Then we with the same methodology as we discussed before, we can we can distribute this weight to this side or to right side and left side, or to the upside, upper side and downside to find the outrigger forces. Once we get this, once we get the reaction for this, let's say this outrigger 1, outrigger 2, outrigger 3, and outrigger 4. Uh, Once we get the outrigger 4 plus outrigger 1, then we continue with to distribute to outrigger 1 and 4, like that. Same process as previous calculation. So yeah, but the task is only up until the find the COG location. But if you have a case like this, if you want to find the outrigger forces, then you will easily find the reaction by using the previous calculation like that. So this only until the COG location. And then we continue with the task number 3. This is the cases. So in weighing, by using compression jack, we get the load cells reading here, SPT 1, 2, 3, and 4. This is the load cells reading. So for the SPT1 is here, SPT2 here, 3, 4, and the coordinates Cartesian is axis is X will be here to this direction and Y is to this direction. So yeah, the coordinate is for SPT2 exactly at the origin point. SPT2, SPT3, SPT4, and SPT4. So we have the coordinates for each compression cell. So we just combine that using the same formula to get the location of the COG like that. And then the task 4 is the upending. We have columns here. Weight mass is 150 tons. We have two cranes, main crane at the front and tail crane is at the back. So we need to find the crane slot during 0 degree, 45 degrees, 60 degrees, and 90 degrees. But to find the crane loads, we need to consider the offset here, 3 meters, because it will impact to the, because to find the crane loads, we will use like this, right? We will simplify like this. This is the tail crane and this is the main crane. Let's say this is tail crane, main crane, and the load will be sitting here. Let's say it's A and B. A and B. Now the B, it will be easily, it will be, we only use this 20.1 meters distance. It depends on the angle, of course, but we only apply this 20.20. For example, we during 45 degree we have B equals B equals is 20. B equals 20.1 times cos 45. So we just refers to the 20.1. But for A, there is the offset that should be considered. Let's say during 45 degree, the COG is here. There is A axon and B axon, which is A axon is 3 meters times sin 45. So this offset will be will impact the of
I think that your voice unstable again, Nelson.
distance. So be careful. Right.
Okay, now it's okay.
Hello.
Yeah, now it's okay.
Yeah. So yeah, we need to consider for to calculate the A, we need to consider the offset 3 meters. So be careful with the offset like that. Is there any question with regards to the capstone project?
Yeah, any question to your capstone project? Jackson, Aiman, and Ahmed, do you have any question regarding this explanation for your capstone project, or is everything clear? Any question?
So if you find maybe you need to, if you have find difficulties to do some of the tasks, you can free just message me and you can ask anything you want.
So
Is, yeah.
is it clear for you, for all of you? Jackson, Jason, Ahmed, and Ayman?
Can we go to the SPMT question?
Oh, to the SPMT. Ah, sorry. Sorry. Yeah, this one.
No, not this one. On the
Oh, the capstone.
capstone question, yeah.
Actually, there is no
SPP,
SPMT here.
SPD. Sorry. So what is
This
this?
one.
What is this? 0, 20, 0, 0, 18,
That's
18,
that's
20.
the coordinate. So if we still remember how to write the coordinate, so eh, let's say SPT1 0.20, then will be the 0 will be the x, and then the 20 is the y. That's the coordinate in the Cartesian system.
Okay.
Yeah.
Capstone. But it has nothing to do with any calculation or anything, right?
Uh, we only need to find the COG.
Only the COG.
Yeah, only the COG. So this is we use if you're familiar with the compression weighing with the compression jack, the the monitor will be showing us the load reading SPT126. This is the in the table you see the load reading. That's
Okay.
the one we have information from the compression load cells. So to get the COG, we can combine that. We treat the load reading as a load, and then from that, by using the formula as we discussed yesterday, we can find the combined COG. So it will be the same basics for even we use the what is that, the compression load cells. It will be showing the same COG like that. So the table is saying the load reading for each support
Okay.
SPD1, SPD2, 3, and 4. Like that. Is there any question? Is there any other question?
Any other question from all of you?
Got one question.
Yeah.
If let's say the cargo is a column or reactor, so if we want to know the COG, then we must do the weighing first.
Sorry. Uh, your
Oh,
voice is not clear.
okay. If let's say our cargo is a column or reactor,
Mm-hmm.
uh, if we want to know the COG, we need to do the weighing first.
Uh, it depends on what classification you have right there. If it's critical, then you need to do the weighing. But if it's not really critical, then you can just calculate by manually maybe. So yeah, it depends on how critical the object you have right there. I'm not gonna say that is you need to do the weighing, but if it's critical, then yeah, of course you need the weighing like that, Ayman.
Okay, thank you, Nancy.
Yes, no problem. Is there any other question?
Yes, I've seen this measurement showing 14,611.
Mm-hmm.
Then on the other side, there's 9,934. Now,
Yeah.
is it in the middle or we need to, how do we get to know the full end? Getting up to, like from 1 here up to 2, that's where it's showing 9,934. Then if I want to get 1 up to 3 there.
Sorry, I didn't get the question from
On,
you,
on the
Jackson.
same on the same drawing we are currently, there's this area showing, is it Caspian? If I want to get now the full, is it the
Mm-hmm.
measurement from 1 to 3 there?
1, 2, 3, yeah.
Yeah, so is this the measurement? Is this in between 1 and 3? Is 2 in between 1 and 3? Yeah.
No. So we need to if we look at the weighing origin, the origin point is here, right? The origin point is at the SPT2, and the X direction is to this side, and Y is to this side. So when we have like SPT3 18.0, then the X is 18 and the Y is 0. If we look at the origin point is X to the upward here, then this will be 18, correct? The X is 18,
Okay. Okay, I
right?
get the measurements now. Okay.
Yeah.
So
And
that means if I want to get this 2 and 3, I need to subtract this 9,934 from 18. Then I'll get it there. Is
yeah.
that right? Then also
So
on the Y side, if I
mhm,
want to, so we're saying from A to D, that's 20. Because it's
yes,
showing
correct.
SPT1. So if I want to get from
So it will
is
be
this?
20 meters here,
20
right?
meters minus
Yeah.
this one, 14,611. I want
Yeah.
to get this different. Okay.
Yep. Correct.
Understand. Okay.
Yeah.
Okay, I understand.
Because during if we use the compression weighing using the compression, the one should be clear before we doing the operation is the weighing the origin point. We should clear about that so we know where is the exactly the compression load cells located. Then we could by that we can continue with the COG calculation. So before we doing that, the point is we need to clear where is the way the origin and where is the x-axis, y-axis, like that. Otherwise, we all will be mixed up. So we get the COG not correct like that. Is there any other question with regards to the capstone project? Or if you have any question, maybe you can drop me a message directly to my WhatsApp number. I think I have included in the WhatsApp group, so you can just save my number and send me a message through the WhatsApp.
Okay. Okay, I think the other question is, what's the duration for this capstone project when we are supposed to calculate then give you the answers? Or do we start now? It's got a time frame.
The actually there is no time frame, so you can do because the point is we are not we don't want to get the just do that, and so we can discuss more about this. So even it's not correct or whatever, it's not, it doesn't matter. So once you get the incorrect answer, I will reply with the correct approach. So it will be, there are two communication ways between us, because there is, it's not like to find the point after you finish the class. It's about the communication between two ways, two persons. So yeah, that's from me.
So maybe I will explain a little bit about our capstone for all of you. This capstone, we create this capstone for you to understand about our topic, and we don't ask you to do this capstone correctly. If you did this capstone and after that not correct 100%, we will help you to what's the name, to do correctly. So don't be scared, you just do it, and after you submit to us, and then we can discuss together why this is not correct, and then you can understand at the end. And if you ask when you have to submit, if you can submit soon, that's good. We don't give you we don't give you limited time for this, so you can do it when you are free. But we are not going to give you your certificate if you not finish your capstone, because we have to understand if you understand very well or not for this class. So just do it. If you finish one, you just submit to us one, and after that we can correct, we can review, and then if there is something wrong, we can give it to you back, and then we explain to you why this is not correct like this. So it's not like examination. No, this is a capstone. We work together, so we have a communication two-way between you and us, and we know exactly you understand very well our class, kind of like that. It's clear, yeah, Jackson? So there is no limited time. You can do it when you are free. Some people, they finish their capstone after 1 month, but some people finish their capstone in 1 week, and there is one participant, they finish their capstone in 1 day, because they just want to finish soon, and then after that we can we give it a certificate. And then there is participant, I think that they did 6 times, yeah, Nelson, yeah?
Yeah.
Time review 6 times, and after 6 times submit, they get correct 100%. So we will guide you. We will guide you until you get 100% correct. Like this. Is it clear, Jackson?
Yeah, it's clear. It's clear. So,
Yes.
do you have to, when I do the calculation for the capstone, I need to capture on WhatsApp and send to Nelson? Or how
Yes.
do I submit them?
Yes. You can send directly to Nelson, or I will give you our administration team, so you can send by email, or you can send directly to Nelson. That's fine. And after that, Nelson will check your capstone, and if there is something wrong, he will contact you, and then you can discuss 101. So you will get understand very well. Like this. So at the end, like COG or force or load distribution is not become nightmare anymore, right? Maybe like this in the class, you still catching, right? Try to understand. But when you have discussion, person and person with Nelson, you will ask freely. You can ask if you don't understand, and you will get fully understand about this topic. Okay. So that's why our participant from previous class, they love our capstone, because this capstone make a connection between our participant and us. So we know exactly which point that you still not understand during the capstone. During this capstone, we know exactly, and then we start to build a good communication, also two-way learning. Not only one direction, not only we give it to you during the class, but also we give you the capstone and let's discuss together, like that. Okay, so Ahmed, Aiman, Jason, and Jackson, do you still have any question regarding our capstone?
No question.
No question, yeah. So, Jason, do you have any question?
No questions. No questions.
So, thank you so much. If you don't have any question anymore, so I would like to say thank you so much for your time today, and then thank you so much also for Nelson to give us your knowledge and experience. I hope that our class this morning can give you better knowledge about force, load weight calculation, load distribution, COG, and also I hope that our capstone can help you even better understand about basic lifting engineering. And then I will give you recording. I will send you recording for our class from yesterday and also today. And also I will give you Google Form feedback. I hope you can fill our Google Form feedback so we can keep going to improve our quality for our participant. And then for the next batch about mobile crane stability, if you are willing to join again with us, so I will send you also link. When I send you a Google Form, I will send you also link for mobile crane stability. And that class we will discuss about COG and also ground bearing support calculation for outrigger and also crawler crane. It's the same. We also give you capstone at the end and study case. Yeah, during that class, we will give you also a lot of study case. Rely on case from site. So we will learn together about outrigger crane and also crawler crane. How to calculate COG how to calculate crane stability based on COG and also ground bearing support. So thank you so much, everyone. Nelson, do you want to give something explanation about your class?
No, I think that's all.
That's all. Yeah. So
Yeah.
thank you so much, everyone. I hope you enjoy our class today, and then see you during capstone project, and I'm looking forward to see you again for the next. Thank you so much and have a good one, everyone.